Okay, so here's a case that's probably going to be a little bit more complicated, and probably going to be interesting to sort of try to find a way to think about this and make it easier if we can. But first, why don't you just explain what the problem is going to say here?
Well, the problem says that there are 3 runners and they're moving at distinct constant speeds. So maybe it's like this guy's slow, this guy's medium, and then this guy's fastest. But they don't have to be like in intervals. So the problem will say that at some point all of the runners will be at least a third of the track away from any other runner.
Okay. So why don't you show me a situation where one of them is lonely?
So maybe the red guy is a lot faster than these other 2. And then he'll go like this. And then at this point, he's a third of the track away.
Okay. All right, cool. And what do you think about this problem with 3 people?
Well, I think there are kind of 2 cases or 2 ways we could look at the problem and try to solve it. So we could try to see like when each of them would become lonely, or we could look for the case when they're all spaced evenly apart, kind of like what we did with 2. So when they're all a third of the track away from each other, they're all lonely at the same time.
Ooh, interesting. Okay.
Because since we don't have exact speeds, looking for a case where just 2 of them become lonely might be difficult.
Wait, who? What do you mean, just 2 become lonely?
Oh, just this one becomes lonely, I guess.
Okay.
Because like this could happen, but we don't have exact speeds, so we don't know. But if we can prove that this case will happen at some point,
oh, okay.
That might be better.
That's actually fascinating. Maybe we can actually just simplify this problem tremendously and prove that no matter what the speeds are, they end up in this sort of equilateral triangle position. Mm-hmm. Always, at some point, no matter what the speeds are. Okay, so what do you think about that? Do you think that is likely to be true?
I think it is likely to be true.
Okay. I think if you let them run for long enough, they'll most likely, at least with 3, all be lonely by that point. But this will happen eventually. Yeah. Although not in specific cases. Like if we had this guy was going if we say the track is 6 kilometers long, this guy's going 1 kilometer an hour, this guy's going 6 kilometers an hour, and this guy's going 3 kilometers an hour, maybe it wouldn't work.
Okay. Well, okay, so I don't know for sure on those numbers.
Yeah. But with multiples, if some speeds are if we get some guys going a multiple of another guy's speed, it might not work.
Okay. Yeah. Interesting. Maybe there would sort of be locked in a pattern, but all right. So let's pretend it's just sort of random speeds. This is an interesting idea, and it looks like there may be cases where it doesn't work. But if we just have random speeds, so that there's not this multiple problem, is there a way we could sort of hand wave, saying that they would eventually end up in an equilateral triangle?
Well,
that's a good sort of concept.
So I had an idea about this.
Okay.
So if we take away the 3rd guy for a second, we know that from what we used last problem, we can find a spot, or many spots actually, where these 2 guys will be exactly a third of a track away by the intermediate value theorem.
Okay.
So then we can take all of those times when they're a third of a track away, and look at the position of the 3rd guy. Mm-hmm. And since we're going to have an infinite amount of those, and we won't have any multiple issues, the 3rd guy will be in every other position eventually.
Okay, interesting.
So eventually we'll find one where he's exactly a third away from the other 2.
Okay, so that is a very good hand-waving proof. of that. It doesn't prove it for absolute sure, but at least gives you a sense that it actually could happen that you get this equilateral triangle. Did you understand that?
Yeah.
Okay, why don't you explain it?
So, we know, well, in the first problem, if we just have the two, and they're going at different speeds, they'll at some point be a third of the track apart.
Uh-huh.
And then, if we just add in a third guy, and we're looking at random speeds, then there would be a lot of these scenarios where they're a third of the track apart.
Mm-hmm.
And if they have random speeds, there are going to be infinitely many of those.
Okay.
And so at some point, since there is random speeds, this person is going to be in all of the positions. So at some point, he'll be here.
Yeah. Okay. Good. That's good hand waving. I like that. I like that. That's a neat idea. I didn't expect to go down that path. But now we'll take a slightly different look. I'll give you an idea now, and we'll see if we can prove a little bit more rigorously that at least one of them becomes lonely.
Okay.
We won't necessarily prove that all three become lonely, but at least one of them becomes lonely.
All right.
Okay.